Hello everyone, welcome back to the channel. In the previous video, we have seen how we can develop a linear regression model to apply it for various applications of your interest. So, in the current video, we will discuss about the concept of correlation and how this correlation can be used for developing good models, for example, in the domain of rainfall runoff modeling. So first we'll try to understand what this correlation means and how this correlation can be used. So the first questions which come up to everyone when they think about correlation is, what is correlation? How can you calculate it? And what are the uses? So we'll get right into the topic and then we will discuss about how we can do this correlation in Matlab. So firstly, what does correlation mean? Correlation, the term itself, is a statistical term which generally represents about how two variables are coordinating with one another. So, in general terms, it refers to how both the variables are in relationship with one another. So, if we take a case in which if both the variables are moving in one direction, then it is termed as positive correlation. Similarly, if the opposite is happening, if one variable is moving in one direction, the other one is moving in other direction, then it is termed as negative correlation. How do we hear about this correlation in general context? Generally, we refer this to as trend. You might be hearing about the concept of trend in various domains, like for example in water resources or stock market or many others, where we see that uh, people say that there is a certain trend in increase in the price of stocks, or there is a certain trend of precipitation going on around the world and in other contexts. So when we try to understand what this trend represents and how it is referring to the correlation, we can say that if the two variables which we were talking about earlier, if they are in coordination, here it is represented that if one variable is increasing, and in the similar context if other is increasing, then it is termed as positive trend. So let's assume if there is a one variable which is increasing, the other variable is also increasing, then it is termed as positive trend. Similarly, if one variable is increasing and the other is decreasing, then it is termed as negative trend. So this concept can be used in wide range of applications. For example, we take suddenly there is a some issue in some mobile, let's assume. Until then, the popularity of the mobile was increasing. Let's say it's some iPhone 10 or some X company which has having a very high demand. And suddenly there was some issue in some phones which caused it to the company to bring back the phones because there was some faulty things happening in it. So what will happen? There was increasing in trend in purchase of an X mobile, but due to the problem of a model or a phone, the popularity of that thing decreased. So what happens here? There is a factor called faultiness in a mobile. So as the faultiness in number of mobiles increases, the popularity of the mobile decreases. So this is what we can relate near to the concept of trend when compared to one concept influencing other concept. So if we go to the other context as well, this can be used in various domains of analysis, as I've mentioned in the given example, although it was not a very correct example, but it generally gives you a picture of what analysis we can do. So some of the examples which we can see is many people have been hearing about climate change recently. So it this concept of trend analysis or understanding the correlation can be used in that context as well is to find out which variables are influencing this climate change. It's not like every variable which we know is causing a positive impact and change. Let's assume temperature is increasing. It is a component which is causing more climate change. So we can say it's a positive. But in the recent times, we have heard that precipitations are decreasing. So as the impact of climate change is increasing, the precipitations are decreasing. So they have a negative trend in between them. Similarly, if we talk in the context of precipitation and discharge also, we can find sometimes higher the precipitation, higher the discharge in most of the contexts. So in this way, we can associate various problems in the world with the terms of trend and correlation with one another. Generally, to understand this correlation, two types of analysis can be done, which are one, autocorrelation and cross correlation. Autocorrelation represents understanding how one variable is having interrelationship with itself. It's like, for example, there is precipitation. You want to find out how precipitation is in relationship with itself. It means you want to predict precipitation. Let's assume you want to predict tomorrow's precipitation, but you cannot just use today's precipitation and predict tomorrow's, right? So you need to have certain amount of data in the background which understands how the precipitation is changing in the previous days. So this term is referred to as lag. So if you understand how many lags can we use, tomorrow's precipitation accuracy increases that much. So to know how precipitation is in relationship with itself will help you to determine the number of lags which you can use to predict tomorrow's precipitation. In the same way, cross correlation represents how two variables are related to one another. As I mentioned in the earlier example of precipitation decreasing due to climate change. So, how many lags can we use to understand that relationship? So, this analysis is quite important to develop a good model, because to develop any good model in a data driven analysis concept, you need backing of data. So, you need to understand how many lags can we use to be able to understand this trend and project it for the future. So, uh, this is the concept which we are going to use to understand how this can be done for a certain variable. So, how can we use this concept and find out the lags in Matlab? In Matlab, finding out this concept is quite easy, as there are two inbuilt functions which are already built in it to facilitate us in finding out these lag functions. For autocorrelation, it is referred to as autocor, and for cross correlation, it is referred to as crosscore. So using these functions, you can identify how an element is having relationship with itself and with other element. So I'll be showing you in detail in MATLAB and explain to you how you can decide this is the number of lags you can use for a dataset. This concludes the part 1 of the video, and the part 2 shows you how you can use the same concept in MATLAB and understand what each element in the results represent and how you can use them for your further analysis. So until then, if you understood the concept, please give a like and subscribe to the video, and let me know any questions which you have in the comments so that I can answer them. See you in the next video.